All right. Hello, everyone. Welcome to Comp 2150. It's Pi Day today. Yay. Yay. I hope that all of you have pies at home to celebrate Pi Day. My preference is pecan pie. I've got a pecan pie at home. If you're really desperate, I think that the convenience store has like little tarts you can buy. Or you can get a pizza. I don't know. Pi Day is a big day in my house. Pi Day is a very big day in my house. We like to celebrate. Yeah. I apologize for the lighting in this room again. I'm sorry. I can't do anything about it. IST knows about it. I don't know what they actually need to do in this room to get these lights at the front to shut off again, but they're just stuck on as bright as possible. So I'm sorry. I'm sorry. Maybe next time I should like bring a slingshot and just like shoot them out or something. I don't know. Today, what I want to do is spend some time talking about packages. So I want to just finish that up. We had this really feverish demonstration at the end of last class, and I just want to like take my time to go through it, step through it, and talk about how protected is different than we think it is, what package private is, and then just packages in general. So making sure that we all understand one thing about packages. I want to spend some time talking about interfaces today, but we've already introduced this idea of interfaces before. When we were talking about those 9 forms of inheritance, one of those 9 forms of inheritance was specification. And specification is this idea that we have this super type that we're inheriting from, but all it does is specify behavior. It just has methods that we're describing on it. And I told you a little bit about this interface type in Java. And I want to just more formally go through it, but the purpose of that part of the lecture for today is to prepare you for assignment 3. Assignment 3 is going to be published tomorrow. And the expectation for that is we will be providing you with a whole bunch of interfaces that you must implement and use in an implementation of something. I will go over assignment 3 next Tuesday. The last thing that we have here is review, and review is because we have a test on Thursday. So I want to just do a quick bit of review. Yes, yes. Yes, it's Java, yes. So whenever you hear the word interface, like interface as a type, that's actually a Java-specific thing. There is no interface type in C++, so we kind of have to do Java. And then just so we're on the same page, the assignment 4 will be in JavaScript. So assignment 3 is in Java, assignment 4 is in JavaScript. So we're not doing C++ on an assignment again. I see some cheers. Yeah, good, good. I'm glad we all share the same sentiment about C++. All right, so I just did that, so I'm going to skip over that. I kind of walked through these definitions last class, but it was a bit of a quick, fast-paced example set. And I just want to step through the example set again. Again, just to make sure that we're on the same page about what all of this means. So packages, this is that physical and logical organization of classes. That much is okay. We made directories, we imported, we had the package statement. The main things that I want to focus on today are the protected access modifier does not mean what you think it means. It doesn't mean what you think it means. It has a different meaning than expected. And there's an idea of a package private modifier, which is to not specify an access modifier at all. So let's take a look at some code. I've got a set of classes here that are related to each other in the sense that they have a package. So this file is called main.java, and it doesn't have a package specification. So this is not part of any package. Inside of this shapes package, we have this type circle. So it's nothing. It just has a couple of properties in it. One of them is protected. The other doesn't have any access modifier. We have this other type, not circle. And not circle is not related to circle in any way. It's not related to circle in any way. There's no inheritance relationship here. There's nothing like that's making these things connected to each other. outside of the fact that they are in the same package. They have the same package. So at the top of both not circle and at the top of circle here, they are in the same package. That is the only relationship between these two things. The first thing that we're talking about today is that the keyword protected does not mean what you think it means. Starting at 1020, protected is class hierarchy. Things that are below this type in the class hierarchy have access to this property as though it's public. So in the case of circle here, things that extend circle have access to this sides property because it is marked as protected. That is true. That is indeed true. However, protected is an access modifier that is accessible to other classes in the package that share a package with the class that has the protected modifier. So we've got this class not circle. It does not extend circle. It doesn't extend circle. I can have an instance of circle in this class, and I'm going to say C is equal to new circle. And what I can do, because I am in the same package as this class, is I can say C.sides is equal to, circles just have a lot of sides. That's maybe too big for integer. Circles have a lot of sides. That is perfectly acceptable. Because I am in the same package as this class, I have access to its protected instance variables. I can access them without accessors, and I can mutate them without mutators. Yes?
So protected is pretty much public inside that package, but private.
It's public within the package and public to the interface that you've got below you. So like all of the classes that extend from you have access to it, but also classes that don't extend from you, as long as they're in the same package, have access to it. Yes. Yeah. That is an unexpected side effect of the protected access modifier. That's not something that we were, at least that's not something that I was expecting when I started looking at this stuff. Okay, so that's the protected access modifier. It does mean what you think it means, but it means more than what you think it means. The other access modifier that's relevant here is the package private access modifier, which is no access modifier at all. The package private access modifier means that other classes in the same package can access that. So I can say diameter is equal to some number. That's fine. That makes perfectly good sense. Classes that extend a class that are in the same package. So this is another circle. Another circle is in the package shapes here, and it extends circle. They have access to it, so that much is still true. But if I have classes that are outside of that package, so I'm going to say yet another circle, .java. It's a class. It extends circle. I need to import circle here because we're not in the same package anymore. So shapes.circle. I can extend that. But within this class now, I don't have access to that. Even though it's in my superclass, it doesn't have an access modifier, so I don't have permission to access it because it's in a different package. Yet another circle here is in a package. It's in a package, but it's not in the same package as the circle class. And because it's not in the same package as the circle class has marked this as package private by not having an access modifier on it. Even though it's in that extension is a hierarchy, it doesn't have access to that property. We okay with that? Okay. This is a link. So if you're looking at these slides, you can click on this access control documentation here. It has this table that I think is pretty good. It describes accurately all of the different access modifiers that are available for you on Java things. Public means exactly what you think it means. Everything everywhere has access to this. Protected, things that are within the class have access to it. Things that are within the package have access to it, and subclasses, but not everybody else. No modifier is just within the package and the class, but not subclasses. And then private is just within that class unit itself, and nothing else has access to it. Yeah.
So if you had a subclass in like your circle that's shape package, but then you had a subclass outside, so then you couldn't access the diameter.
Yeah. So I want to make sure that I'm talking about the same thing. This class, yet another circle, is outside of that shapes package, so it doesn't have access to diameter. But if we created a subclass within this package, so another circle here, it does have access to it. Yeah. Okay, good. The last thing that I want to talk about with packages is that all Java classes are in a package. All Java classes are in a package. If you do not state a package, they are in what's called the default package. They're just in a package that is the empty package. So if you don't have a subfolder, if you don't have a package keyword being used at the top of the class, all of the classes are part of the default package. So if I were to take all of these classes, I'm just going to close all these files. If I were to take these and just move them into or out of that shapes package, and then just delete all of the package keywords, which I guess Visual Studio Code has helpfully done for me, they're all in the same package now. It's unstated what the name of that package is. It doesn't have a name, but they're all in a package. So this example is still working where we have situations like circle has this value protected, and everything else that happens to be in this package, including main now here, has access to things like, whoa, C dot sides. This is now fine. They're all in the same package. So protected no longer really has much meaning because they're all in the same package. All classes in Java all have packages, whether we have stated it or not. All right. Okay, packages are over. We're done. We're done with packages. Great. Let's move on and talk a little bit about interfaces. So we talked a lot about different forms of inheritance. We've got these 9 different forms of inheritance. One of the ones that we talked about was specification. And the idea of specification is we have a supertype, we have a supertype, and that supertype, all it does is specify behavior. Here are all the methods that something that extends or implements this class must implement. They have to be able to do all of those things. C++, the only way to do this is with virtual methods, pure virtual methods and abstract classes. That's the only option that we have in C++. But in Java, we have a special type called interfaces that allow us to specify behavior without specifying implementation. An interface in Java gives us the ability to specify behavior, so can do without specifying implementation. Here's an interface in Java. We use public. We use the keyword interface. We name it like we name a class, so uppercase first letter, and then everything else after that lowercase, and we use snake case. And then we define or declare a bunch of methods. So we provide a list of the method signatures that something that uses this interface is going to be required to implement. We don't put any implementations of methods in these interfaces. They are just method signatures. That's it. We have to name variables, but we don't have to actually use those variables in any way inside the method signature. Usually we don't have implementations. The public keyword is not required on method signatures here because it's implied that all methods on an interface are public. An interface is used purely to say something that implements this interface has these methods, and that's it. It doesn't really have to say anything about private or protected because that's implementation details. That's how this class might internally do something. The methods that we state on an interface are the methods that this class can do to things that are outside of it. So everything is going to be public by default, so we don't have to specify public. It's not illegal, it's not a syntax error to put the public keyword on there. You're not going to get warnings or anything, but it's not required to put the public keyword on there. Importantly, interfaces do not have instance variables. There is no state in an interface. This only declares the things that a class can do. There is no state, there's no instance variables. There's nothing that we need to hide or encapsulate in an interface. This is just a specification of what a class is able to do when it implements an interface. To have a class implement an interface, we declare a class kind of as we normally would, public class, and then we use the implements keyword, and then we specify the interface that we want to implement. By implementing an interface, so this square class implements this interface principle, that means that this class has to have a public method that implements what is defined in the interface. So it actually has to define the method. It has to provide the implementation of that thing. An individual class can implement several interfaces. This is different from inheritance in Java now. In inheritance with Java, we can have one parent, exactly one parent. With interfaces, we can implement as many interfaces as we want. I think there's probably a limit, but I don't know what the limit is. And if you're hitting the limit, you're going too far. But you can do multiple interfaces. You can implement multiple interfaces. An interface does not define state. It doesn't define state. There's no state. In C++, we can have multiple inheritance. We can have several parent classes. When we inherit from each of those different classes, we get all of the state for all of those objects and classes inherited. We get all of that stuff. An interface only specifies behavior. There's no state. So we can implement as many interfaces as we want because all this says is, I've got that method. That's all it says. I will implement this method. I have this method. I can do this thing. But it doesn't say anything about state. Interfaces in Java, it's a type that you can use just like a type. So what I mean by that is any place that you can declare a class, you can declare a variable that has a static type that is a class. You can declare a variable that has a static type that is an interface. So if I have an interface called printable, and the interface printable has a print method, then I can declare a variable that is of type printable. I can assign to a variable that has that type any kind of class that implements this type. And it doesn't have to be related to any other class hierarchically in terms of inheritance. All that we have to have is that this class that we're assigning to that type implements that interface. Yes, and it has to explicitly mark that it implements that interface. So it must say implements in whatever that interface is. So in this case, it has to have printable here if I want to be able to assign it to a type of variable printable. Yeah, yes?
Would you be able to do printable p equals new printable?
No, no. This doesn't have any state. So it also is not instantiatable. You can't create an instance of something that doesn't have state, because all it does is define behavior. Okay, everybody just shut off for a second. We're not going to do this in assignments, but for completeness, just for completeness, I feel obligated to do this. I'm going to make this interface printable. I'm going to say void print. And in my main, I'm going to say printable p is equal to new printable. Okay, I just told you can't do this. I just told you can't do this, but you can do this if you use an anonymous inner class. This is like weird, in the weeds Java stuff. This is a class. It's just like inline in the code that I've written. You don't need to do this. Don't do this. Don't do this. Please don't do this.
Is this one of your naughty tricks from 3350?
I do use this in 3350, yes, but for a limited amount of time, because we immediately switch away to not doing this because it's bad. Okay, so I'm just going to erase that. So for completeness, the answer to your question is yes, you can, but please don't. Anywhere you can have a variable, anywhere you can give a type to a variable, you can use an interface. Yes, yes.
So if you're types, can you cast a variable to a different interface?
As long as it implements that interface, otherwise you will get like a class cast exception because it can't be castable to that. So that also means, thank you for that. That kind of leads to another point. Because interfaces are type, you can do things like, so let's go, we've got printable still here. So let's go to circle and let's say that it implements printable. So now we're forced to implement a print method because we've just declared that we're implementing this interface. Visual Studio Code is helpful in that you can do a quick fix here and it will add unimplemented methods. Just generate some code for you. That's kind of nice. This is an annotation. And so let me see. I'm going to say system.out.println printf. This diameter of the circle is d. So anywhere that I use this circle type, I can do something like this. I can say something like if C instance of printable, because this is just a type, it is just a type. So I can ask, does this specific instance of this thing satisfy this? Is it an instance of this interface? And then I can say printable P is equal to printable C. You can cast it to that type. Just change the type of that thing. Any place I refer to this later now, I can only use the printable interface though. So if I'm talking about the variable P here, because it's just that specific type, that's all I can refer to. That answer your question? Yeah. Okay, good. So that also means though, that anywhere you can accept arguments, so give a type to a variable, any place you can return things, you can use these as argument types and you can use them as return types because it is just another kind of type in Java. Now you might be asking immediately, we can already do this. I can already do this. We can already do this. We've got this abstract class idea. You can do this in C++ with abstract classes. Why are we doing this stuff with interfaces? The problem with classes in Java is that a class can provide state and implementations. Even if we know, like we're sitting down at the machine and we're typing out these abstract class definitions, and we just don't put instance variables and we don't put method definitions inside of that class, the language says, Java as a language says, you can have instance variables and you can have methods that are implemented inside of this thing. Classes, whether we write that stuff out or not, can provide state and implementations. If you have a subclass of an abstract class, it inherits all of that state and implemented behavior. An interface doesn't provide state. It doesn't provide any state at all. It doesn't provide any state or implementations usually. All it's saying is classes that implement this specific interface can satisfy a protocol. They inherit a protocol. Protocol here means they can do these things. They can do all of these things that I've defined, but that's all I'm going to be able to tell you about that based on the static type that I have right now. Interfaces, similar to classes, can extend other interfaces, but the difference is we can extend as many interfaces as we want. So on my first line here, I have public interface my list item, and I have this interface extending two others. So I'm taking two interfaces and I'm kind of combining them together into one thing here. If I have a class that implements my list item, I have to implement all of the behaviors that come from all of those different interfaces now. It's just taking all those different things and kind of saying, these are all of the methods that you must satisfy, that you have to have implemented as part of you. This is equivalent to just listing out all of those interfaces on the class definition itself. Again, all it's saying is something that implements this must have these method implementations. Interfaces generally do not specify behavior. Almost always do not specify behavior, but they can specify behavior in the form of something called a default method. A default method on an interface is a method implementation that is in fact attached to an interface. Okay, so they can provide implementations sometimes. Usually what this is used for is if you know that all classes that implement this interface will want to use some common behavior. Okay, now we're starting to get back towards like classes and inheritance again. Or if you have an interface that you previously defined and many classes implement it, you can add a default method, some new behavior to classes. Default methods can only refer to other methods in the interface. There's no state. They don't know anything about other objects. They can refer to other classes by type. They could create instances of objects, but they can't really refer to any state within the interface because there's no state within the interface. They also can't replace methods on the object class. So remember that Java's got this big object class at the top of the entire hierarchy for everything. There are certain methods that are part of the object definition, so toString and hash code. You can't provide default implementations for those with default interfaces, default interface methods. If you have a class that extends another class and implements something that has a default method, if there's a name collision there, the implementation from the superclass takes precedence. That's kind of it. That's kind of all I want to do about interfaces. It's not really like, I don't find it to be that big of a topic. I don't think it's that big of a topic. But this is enough to get you started on assignment 3 when you start taking a look at it tomorrow, because you're all going to be really eager to take a look at that, I know, yeah. But you will be able to take a look at it tomorrow and start to get a sense of what it looks like. Are there any questions about interfaces before I move on? Okay, good, cool. All right. Let's do a little bit of review. So we have a test on Thursday. Like, hooray and surprise, we have a test on Thursday. The structure of the test is similar to a test 1. So we'll have a multiple choice section, we'll have a short answer section, and then we'll have a longer programming section. The time amount for this test is also the same as test 1. So we're limited to 50 minutes because the other section is limited to 50 minutes. We'll start the test as soon as class time starts. And I will stick around afterward if you want to talk to me. But you're otherwise free to go work on your assignment after the test is done. Yeah. The topics that are covered are between weeks 5 and 9. So it goes up to but not including interfaces. We're not doing interfaces on the test. Up to but not including interfaces. Okay, up to but not including interfaces. Yes, good. Week 5 seems like an eternity ago. It seems like an eternity ago at this point because we had a winter break in between those times. Week 5 was where we were talking about method and variable replacement in inheritance hierarchies. So we talked about those terms like shadowing, where we can have multiple methods that have the same name, and how that behavior differs in C++ and Java, where we can have variables that have the same name between subclass and parent class, and how that behavior differs between Java and C++. We have this idea of covariance and contravariance between arguments and return types in methods on classes. The fact that Java is a non-variant language, so if you have something that has a method that's defined in a supertype with a superclass argument, and a subclass has a method that's defined with a subclass argument, they are different methods. They're not the same method. There's no polymorphic behavior there. They're just different methods on those classes. And then the idea of refinement, so taking a method and then having a subclass called superdot. Yes? So C++ is a non-variant language in the same way that Java is, in that if you have covariant argument types to a method between parent and subclass, they are just different methods. So it's non-variant in that way. Both Java and C++ allow covariance on return types, though. So you can have superclass-subclass relationship between return types on methods, and they will behave polymorphically the way that you're expecting them to. Yeah. We talked about the orthodox canonical class form. I did it. I said it. Good. We talked about that. So we define null constructor, destructor, copy constructor, assignment operator in classes in C++. We talked about object references and then ownership of pointers related to the idea of I own this object, so it's safe for me to call a destructor on it. I can safely delete this pointer because I am the one who owns this thing, as opposed to me maybe not owning it and I don't know who owns it. We talked about substitution, specifically in the way of Liskov's substitution principle. Liskov's substitution principle is very much about there is a type. The type defines a contract. When we have subtypes of that, for it to be substitutable for the supertype, we should satisfy the contract that's stated in that supertype. We have a list. It has an add operation. I should add things to myself if I am satisfying Liskov's substitution principle when that add method is called on me and I am a subtype of list. We talked about 9 forms of inheritance, where one of them was not really a form of inheritance at all. We talked about the side effects of substitution, so dynamic class binding and using static objects, so stack allocated, not static, stack allocated objects, and how going back and forth between supertype and subtype, we kind of lose stuff because we're using stack allocated variables. And then just days ago, we talked about encapsulation and packages. Let's have a quiz. Is that a fork bomb? So this, if anybody sends you something like that and they say, hey, paste this into your terminal, don't paste it into your terminal. Hiya, okay. Okay, I'm gonna start it. The game pin will stay up throughout the game. You can assume that there are implementations of these methods somewhere. Okay, good. Good, good, good. Okay, so this is shadowing in C++. This is shadowing of methods in C++. The first thing that we've got here is a class that's our super type that defines this method called area that has a return type of float. We extend that class and we have a method that has the same name. It has the same name, but they are different methods. They are not the same method. Because in our super type, we didn't declare this as virtual. We didn't declare it as virtual. It's not a method that can be overridden. They are just two different methods. If we have a method on our super type here, so on line 2, our static type for this variable s is shape. If we call a method on a static type that's not marked as virtual, it's not going to descend in the hierarchy to find the implementation for the instance that you have. It's just going to call the method on the static type. So this is method shadowing in C++. All right. So I know these classes are empty. I know they're empty, but the idea with a subclass is we'd have something extra there. There'd be something extra there. When we've got these stack allocated variables, we've got stack frames. We've got a thing that we're calling, and we're allocated just a certain amount of memory for that stack frame that we're currently executing in. In this super type object, there's only enough memory allocated for that object, for that type. So the super type has some number of properties, our subtype has some additional properties, but because this is a stack allocated variable, the stack frame only has enough memory for that one thing, for that set of properties that's in the super type. We can go up like this in the same way that we go from floating point numbers to integer numbers. We just truncate the decimal point. We can do that. There's a bad example because we can go back from int to float, but we can't go back with classes like this because we don't know what that extra stuff is supposed to be, and we don't really know what the right default values are for this. We can make an assignment operator to do this. We can create that method if we want to. But we're still in that state of, I don't know what goes here. I don't know what goes here. Whatever was there is now lost, and I just can't get it back. It's not possible for me to get it back. Is that okay? Okay. Okay, okay. Just for reference, though, this is a true statement. Stack allocated objects cannot be polymorphic. They're not polymorphic. So if you do assign some subtype to the supertype and you call methods on it, it's still just calling them on the supertype. It's not going to go down the hierarchy there. Dynamic cast is about pointers and not stack allocated stuff. All right. Whoa, okay. Oh, no. Here's the code. I'm just gonna leave it up. I'm gonna leave it up for like 10 seconds. I'm just gonna let you read it, okay? Without pressure, no pressure. Okay. So I'm gonna do this first. So the name of the file here is 2cpp covariance.cpp. And the error that we're getting back here is it's marked, this method is marked override, but it doesn't override anything. So this calc area and this calc area, this is covariant argument types. We've got the supertype in the superclass for the argument type. We have the subtype in the subclass for the argument type. But these are just different methods. They're just different methods. They're not the same method in C++. So even though this is marked as virtual, that does say you are allowed to override this thing. You are allowed to override it in the subclass. And we have stated we have intention to override something in our superclass. Because these are not the same types here. They are covariant types, but they're not the same type. They're different methods. They're just different methods. C++ in terms of arguments is a non-variant language. If I change this to shape, and let me change it down here as well in the implementation. If I make them have the same type, now it compiles. Now it's okay. But in the state that it was in originally, because they are different types, even though they are hierarchically related to each other, they're covariant, they're different methods, so it doesn't actually compile. We okay? Okay, okay. I guess it just stays the same, yeah. Oh no, it just stayed the same. Okay, good, 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 good. So I'm going to pop this up. Here's the code. This is the code that you were just looking at. The difference here from the last example is that we've got the return type as covariant on these two methods. C++ and Java, this applies to both languages. C++ and Java are not, they're non-variant for arguments, but they are allowing covariance for return types. This is the one place where both C++ and Java allow covariance to happen, and what you would expect to happen is what happens. And I'll make it just for posterity, I guess. It's 3. I built it already. It's already up to date. Okay, so this is the behavior that you would expect. So I'm going to go down here and just take a look at my main method, main function. It's calling the method that you're expecting it to call. And it's because of the return type itself. The return types are allowed to be covariant. They're allowed to be covariant. Okay, okay. I can make it available. It's not up there yet, but I can put it there, yeah. You don't want to retype this code watching YouTube videos? I can put them online. They're already typed out. It's fine. How are I write make? Oh, there's actually no make file in this directory. Yes, so you can use make without specifying a make file in this. This is a digression. This is a complete digression. There are no questions about make on this test. There's no questions about make files or make. You can just run make and give it the name of the target that you want it to create, and then it will use those implicit rules to just generate that thing. Yeah. So I don't have a make file in here. I'm just using make. Yeah. So there's nothing for me to put online. I'm sorry. Okay, good, 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 good. M is staying at the top. Okay. So here, let's take a look at this again. We've got these two methods. Super implements a method called method. Sub implements a method called method. They're different types. They're not the same method. They are not non-variants, right? We've got non-variants on arguments to methods. But the difference between this and what we were doing in the last examples is that we're moving up in the hierarchy for the subclass implementation of that method. So covariance is going down the hierarchy. If this was method super in the superclass and method sub in the subclass, that's covariance. That's moving down the hierarchy. But in this case, we're moving up the hierarchy. We're going to hyper for the argument type in the subclass. So this is contravariance. We're moving up the hierarchy of classes. Similar to covariant methods, these are different methods. So calling them with different types is going to result in different outputs and expectations. I wish I could rename this person to the correct name. If you can rename yourself, please do so. Okay. I can't tell if no, it's fine. Thank you for trying. I appreciate you trying. Okay, good, great. I realize, like staring at this, the question that I've asked is, why can't we just call super? And then in the code, I have super parenthesis. That was unintentional. I didn't mean it that way. I'm glad that we didn't think it was that way. So we've got here a subclass. It extends something. And then when we have the constructor on the subclass, we must call the super constructor by name explicitly. We can't just do super. C++ classes can have multiple inheritance. So if we extend multiple classes, we must specify which constructor we're trying to call. So if we have two parents, we have to call those two constructors separately. We have to pass different things to them. We're going to talk about multiple inheritance later. C++ is going to come back to haunt us, but like just in an academic sense, as opposed to you got to do this on an assignment. C++ has multiple inheritance, and there are consequences to multiple inheritance. We have to specify the name of the constructor, even if we're only extending one class, because of the fact that it can extend multiple classes. And for the record, the syntax for calling it is the initializer syntax. You have to use that colon and then the name of the class constructor itself after that. We can't put it in the body of this because if you try to refer to a constructor from within the body, it would try to create an instance of that type, and that's not what we want. We just want to refer to the constructor of the superclass, so we have to use that initializer syntax. But okay, we're good. Good, 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 good. The big difference, the big difference is that they're different things. An object reference is an address. A pointer is a variable that has an address in it. An object reference cannot be polymorphic. We can pass an argument to something that accepts a reference to an object reference. Oh my God. We can pass something to an object reference that is of a subtype. We can do that. But it does behave like a stack variable afterwards. The best answer here, though, is one is an address. The other is a variable that has an address in it. Is that okay? It's okay? Okay. This is like the same people are at the top and they're just like switching here. Okay, so I'm delighted that some people are saying that types are only substitutable in lumpy space. So Liskov substitution principle is very much about, we have a type, we've got a type, and the type defines a contract. It defines a contract by saying things like, I have all of these methods on me. I've got all these methods. When you call this method, you as devs, as people that are using this class, you should expect certain behaviors out of that class. You as a person should expect certain behaviors out of implementations of this class that are subtypes of this thing that satisfy this contract. If I extend a class, I should be able to replace it. I should be able to substitute it with that supertype. So I have the supertype. I should be able to put an instance of the subtype in the supertype. And I shouldn't have to expect any changes to the way that I'm already interacting with that type. So if I have a list and I have an add method, if I extend my list type as a set, that was our example that we did in class where we kind of broke the contract. Lists, the contract there is, as you add things to it, they should all be in the collection. A set, as you add things to it, will reject duplicates from being put into that collection. A set, if it extends a list, breaks that contract. It breaks that contract that's defined in the supertype. Subtypes inherit all behavior from supertypes. It's sort of like these ideas are related to one another, but Liskov's substitution principle is not really saying that it inherits anything. It's just that it satisfies the contract of that type. We can substitute any subtype for a supertype anytime. That's the goal of Liskov's substitution principle, but that's not what it's actually trying to measure. What it's actually trying to measure is, does this subtype actually satisfy the contract that's defined by the supertype? Is that okay? I'm willing to just stop for a couple seconds and take a breath here.
You don't like the color red,
I'll be honest with you, I turned the randomize answers option on, so I can't even predict which one's going to be the correct color or shape in Kahoot. So by that, you could say that Kahoot hates red, or at least its random number generator hates red. Okay. Well, okay, wow, that moved a lot. Okay, here is the last question. Okay. All right. Okay. So, forms of inheritance. Okay, I'm gonna try this. We've got specialization, specification, generalization, variance, extension, containment. I already said variance. I can't do it. I can't even do it. Containment is that has a relationship. So we're not actually extending anything with this form of inheritance. There is no extension going on here. The idea of containment is that we are taking an object that we want to use because it has desirable properties and we are embedding it in ourselves. So we have a list of things as opposed to saying that we extend a list. The example that we used for this specific idea was that, again, that set and list thing. As opposed to having our set extends list and implying an is a relationship, we now have a set has a list inside of it, and we control the interface and we define the interface for the type that we've got. So it doesn't really use inheritance because it's just containment. It's taking some other class and using it as an instance variable as opposed to something else. I don't care. Congratulations, man. Congratulations, man. You did it. Okay, great. All right. So that's kind of it today. I think this is a reasonable place to stop. I feel like you are in a state where you can start assignment 3, and I don't want to start jamming more stuff that's completely unrelated to the test on top of what you've got right now. So at this point, do you have a question, Sanjam? There is a question about Java, or that uses Java on the test, yes. Yes. Okay. With what we've done before the quiz, you should be able to use access modifiers appropriately. So this is related to what we finished with last time. Protected by default, that default behavior of I'm going to put protected on all of my instance variables is not acceptable anymore in this class. Everything should be private. All internal properties should be private. Mutators should be protected, and we should be enforcing constraints in things like mutators. So actually saying, I have an assumption about this value that's my private instance variable. I am going to enforce it in my mutator and not just blindly accept stuff. You should be able to define the term package private. So no access modifier, meaning classes that are outside of the package that extend this class cannot have access to it. Other things that are within the package have access to it, even if they don't extend something. Yes, please.
Is the test already made up and ready for the printers?
Yes.
Can modifications be made?
I am confused by your question. Oh, no. I've just revealed you tried to access the I don't know if you're trying to make a joke or not. I can't tell. Are you trying to make a joke?
No, I'll be good for the test.
All right. You should be able to use interfaces in a Java program. I'll see you all on Thursday.